So I was doing this problem and my phone died and I just blathered on blah, 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 blah. So now I have to go back and redo this problem, or at least, go back to where we were. So we were solving Gaussian elimination. We're trying to make that triangle method, and we've gotten to this point. So now we're trying to eliminate this y value. So we're going to look at these two equations. And the only way the y value is going to go away is if we multiply this guy by a 5. So we're going to have e sub 2 plus 5e sub 3. And we'll put that in the new for e sub 3. Okay. So again, scratch work down below. Negative 10y plus 7z equals 42. Multiply by 5 now. So that's going to be 10y minus 10z equals, and negative 12 times 5 is going to be negative 60. So when we combine there, we're going to have negative 3z, right, because these guys go away, equals negative 18. So we can actually continue on and write this as z equals 6. Everybody okay with that one? Okay, so squiggly bracket. Top guy, 3x minus y plus z equals 3. Middle guy is minus 10y plus 7z equals 42. And now the bottom guy is going to be just z equals 6. And so what we've done is we've gotten it into that triangular form using our Gaussian elimination. So now what we're going to do is we're going to work our way back up through. From the bottom, we're going to take the z and stick it in here. Then we're going to have the z and the y and stick it in there and finally get our x. So we'll go all the way back through. So we'll take this and stick it right there. So we have negative 10y plus 7 times 6 equals 42. Well, funny enough, 7 times 6 does equal 42, so those guys cancel out. So we have negative 10y equals 0, so y equals 0. Now we can plug that in here, the y and the z, so we have 3x minus 0 plus 6 equals 3. Subtract, so we'll have 3x equals negative 3, right, subtract, and so x equals negative 1. So we end up with the point negative 1, 0, 6. Okay. Now, this might not have been the way that you did this when you learned this before. It's certainly not the way that I would normally do it. But for anybody that's headed towards computer science, and if you're looking into computer science, you're definitely going to have to take calculus and all the different maths, then this Gaussian elimination is the method that you need to focus on, and it will become more helpful because we're going to use our calculator. So let's see one more of these just so we can get used to this arrow baloney stuff that's going on and see if we can solve one more of these guys, okay? Let me find one. All right, I don't like any of those, so let me go to the back of the book and see what I can find back here. Nope. What the heck? Oh, never mind. I was looking at the solutions and not the problems. So let's see what one that has all the parts to it. Let's see what 23 is. Oh, hell no. Okay, maybe I should have looked for one before we started. How about 22? There we go, 22. All right. So let's erase this puppy. So number 22 looks like this. So this one says x minus y plus z is equal to 8. 3x plus 3y minus 9z is equal to negative 6. Oh, and this one looks nice. 7x minus 2y plus 5z is equal to 39. And now let me just look at it to make sure I got all my plus or minus signs taken in correctly. I think we're good. Squiggly bracket here. And we're going to go E1, E2, E3. Okay. Now remember, even though this might not be the way you would choose to do this, you know, a year ago, we're using this new Gaussian elimination to make that triangular shape. So it means that we want to get rid of these two x's. So we can get rid of this one using the top equation if we take those two guys, but multiply this guy by a negative 3, right? Take those two guys. So we're going to say take negative 3 E1 plus E2, and that's going to be our new E2. Okay. So we'll do our scratch work right here as we've done before. I'm going to do it with a different color pen if this helps. So we're going to multiply by negative 3. So negative 3x plus 3y minus 3z equals negative 24. And then 3x plus 3y minus 9z equals negative 6. Okay. When we combine there, those guys are going to go away. I don't know if you guys can see this. If you zoom in, here is a spider crawling down the board, wanting to learn some math. So here is 6y minus 12z equals negative 30. Now, this guy all has 6's in common, so another thing we can do before we put it back in there is hold on one second. Mishka, Max, that way, now. Go, take everybody that way. All right, so we can divide everybody by 6, so we can actually say like put divided by 6. So if we divide everybody by 6, we go y minus 2z equals negative 5. And that will make that second equation actually even prettier. So our first equation is still the x minus y plus z equals 8. But our second equation is now y minus 2z equals negative 5. And our third equation is still this guy. Okay, nothing's changed there. Okay. All right, so we got rid of this x here. Now we need to get rid of this x. So this time, we're going to use the top and the bottom, but we need to multiply the top guy by negative 7. So we're going to go negative 7 E1 plus E3 is going to equal our new E3. And I didn't leave myself a lot of space there. So hopefully you have that written down so we can erase our work. And I'll have to come down here. We'll use our little arrow. Okay, so scratch work, we'll put our scratch work right here. I'm going to multiply everybody through by negative 7. So negative 7x plus 7y minus 7z equals negative 56. And then write the third guy down the way he is. All right. And combine them. So x's go away. Here we have 5y. There we're going to have minus 2z. And 50 or 56 minus 39 or the other way around. Let's see, 39, 49, 17, right? And if you're like not sure, so I'm just gonna make sure, we can actually do that on our calculator. Yeah, 17, and it's gonna be a negative 17. Alrighty, so back over here, our top one is still gonna be the same. X minus y plus z equals 8. Y minus 2z equals negative 5. And 5y minus 2z equals negative 17. Okay. So, got rid of that. Now we need to work on this one, okay? So we can get rid of the y if we multiply that second guy by a negative 5. So here, we're going to say negative 5 e2s plus e3, and that will be our new e3. So again, scratch work. We're good with my pen. Scratch work. So negative 5 times this. So negative 5y plus 10z plus 25, right? Okay, bottom guy stays the same. And we combine. So here we will have 8z equals 8. Okay, 8z equals 8. Everybody look at everybody. Okay, and here's one where we can actually simplify further. Like we did in the other one, we can cancel out the 8s and say that z is equal to 1. So, we've got kids running around playing hide and seek, thank you very much. Just what I need when they're trying to do a lecture here. Okay, so top one stays the same. Middle one stays the same. Bottom one now becomes z equals 1. And there's our triangular form. And now the point there is that we can just work our way beep, 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 right back up the line. So if z is equal to 1, we'll say y is equal to 2. Let me do that again, sorry about that. But z is equal to 1, so y minus 2 times 1 is equal to negative 5. So we'll add 2, so y is equal to negative 3. And then we'll go back to the top one, x minus negative 3 plus 1 is equal to 8. So that part right there is going to be 4. So x, subtract the 4, will equal 4. So we end up with 4, negative 3, 1. Alrighty. Okay. So point here is really to refresh the idea, refresh this idea so that when we move into 8.2 and 8.3 and 8.4, we're going to learn something new, but it's going to fall back and help us solve these. And like I said, even though you may not have done this method before when solving this, this method is going to start to become easier once we use our calculator in the next couple lessons, okay? All right, so it took a dead battery and a whole bunch of other stuff, but we got this one finished. All right, 8.2 next.